NENOMATICA, where mathematics meets YouTube excellence. A first-degree equation has the general form ax plus b equals 0, where a and b are constants, and x is our variable that we need to solve for. After simplification, these equations can be written as x equals negative b over a. Let's discuss the different cases we might encounter when solving these equations. Let's examine our first case. Case 1, when a is not equal to 0 and b is not equal to 0. In this case, the equation has one non-zero solution given by x equals negative b over a. Let's see an example to understand this better. Consider the equation 2x plus 6 is equal to 0 here, a equals 2 and b equals 6. Using our formula x equals negative b over a, we substitute the values. X equals negative 6 over 2, which simplifies to negative 3. So the solution to the equation 2x plus 6 is equal to 0 is x equals negative 3. Let's verify this solution by substituting it back into the original equation. When x equals negative 3, we get 2 times negative 3 plus 6, which is negative 6 plus 6, which equals 0. So our solution is correct. Now, let's look at our second case. Case 2, when a is not equal to 0 but b equals 0. In this case, our equation becomes ax equals 0. Since it is not 0, the only solution is x equals 0. Let's see an example. Consider the equation 5x equals 0 here, a equals 5, and b equals 0. Using our formula x equals negative b over a, we get x equals negative 0 over 5, which is just 0. So the solution to the equation 5x equals 0 is x equals 0. Let's verify this. When x equals 0, we get 5 times 0, which equals 0. So our solution is correct. Let's move on to our third case. Case 3, when it equals 0 but b is not equal to 0. In this case, our equation becomes b equals 0. But wait, we know b is not 0, so this statement is false. This means there is no solution to the equation. It's impossible to find a value of x that makes the equation true. Let's see an example. Consider the equation 0x plus 5 is equal to 0 here, a equals 0, and b equals 5. Simplifying, we get 5 is equal to 0, which is clearly false. So, this equation has no solution. It's impossible to find a value of x that would make 0x plus 5 is equal to 0 true. To understand why, think about it. No matter what value we assign to x, 0 times x will always be 0, and 0 plus 5 is equal to 5, which is not equal to 0. Finally, let's look at our fourth case. Case 4, when both a and b equal 0. In this case, our equation becomes 0x plus 0 is equal to 0, which simplifies to 0 is equal to 0. This is always true, regardless of the value of x. So, this equation has infinitely many solutions. Any value of x will satisfy the equation. Let's see an example. Consider the equation 0x plus 0 is equal to 0 here, a equals 0, and b equals 0. Simplifying, we get 0 is equal to 0, which is true for any value of x. So, this equation has infinitely many solutions. Any value we choose for x will satisfy the equation. Let's verify with a few values. If x equals 1, we get 0, 1, plus 0 is equal to 0, which is true. If x equals minus 5, we get 0, minus 5, plus 0 is equal to 0, which is also true. So indeed, any value of x is a solution. Let's summarize what we've learned about solving linear equations of the form x plus b equals 0. Case 1. When a is not equal to 0 and b is not equal to 0, we have one non-zero solution x equals negative b over a. Case 2. When a is not equal to 0 and b equals 0, the solution is x equals 0. Case 3. When a equals 0 and b is not equal to 0, there is no solution. The equation is impossible. Case 4. When both a and b equal 0, there are infinitely many solutions. Any value of x works. These 4 cases cover all possibilities when solving linear equations. Understanding these cases helps us quickly identify what kind of solution to expect when given a linear equation. Let's start with our first example. We need to solve the equation 2 times open parenthesis x minus 1 close parenthesis equals 2x plus 3. Let's solve this step by step. First, we need to expand the left side by distributing the coefficient 2 to each term inside the parentheses. Now, We'll move all terms with x to the left side and all constant terms to the right side. We subtract 2x from both sides. We've reached 0 equals 3, which is clearly a contradiction. This means the equation has no solution. Let's write this in algebraic form to explain why. This is an impossible equation. It cannot be solved because it leads to a contradiction. In algebraic terms, we can express this as b is not equal to 0 and it equals 0, where the standard form of a linear equation is ax plus b equals 0. Let's look at our second example. We need to solve the equation. Open parenthesis 2x plus 1 close parenthesis divided by 2 equals x plus 1/2. Let's first verify what we're looking at. We have the fraction 2x plus 1, all divided by 2, equals x plus 1/2. We can see that the left side and the right side are exactly the same expression. Let's move all terms to one side to see if we get an identity or contradiction. After canceling out the like terms, we get 0 equals 0, which is always true. This means the equation is an identity, and any value of x will satisfy the equation. This equation is satisfied by all real values of x. In algebraic terms, we can express this as b equals 0 and a equals 0, which means that any value of x will work. Welcome to this educational video on solving parametric equations. Today, we'll work through the parametric equation m squared x minus m equals x plus 1, where m is our parameter, and we need to solve for x. Let's begin with our equation. We have m squared x minus m equals x plus 1. In solving parametric equations, we first rearrange to isolate x in terms of m. Let's start solving this step by step. First, we'll rearrange the equation to get all terms with x on the left side and all other terms on the right side. This gives us m squared x minus x equals m plus 1. Next, we factor out x from the left side. So we get x times m squared minus 1 equals m plus 1. Now, we can solve for x by dividing both sides by m squared minus 1. This gives us x equals m plus 1 divided by m squared minus 1. However, we need to be careful here. The denominator m squared minus 1 could be 0, which would make our solution undefined. So we need to analyze special cases. Let's look at case 1, where m squared minus 1 equals 0. Let's solve m squared minus 1 equals 0. We get m squared equals 1, which means m equals plus or minus 1. Let's first consider the subcase, when m equals 1. If we substitute m equals 1 into our original formula for x, we get x equals 1 plus 1 divided by 1 squared minus 1, which is 2 divided by 0. Since we can't divide by 0, we need to go back to our original equation. When m equals 1, the equation becomes 1 squared times x minus 1 equals x plus 1, which simplifies to x minus 1 equals x plus 1. Rearranging, we get negative 1 equals 1, which is a contradiction. Therefore, when m equals 1, there is no solution. Now, let's consider the subcase, when m equals negative 1. If we substitute m equals negative 1 into our formula for x, we get x equals negative 1 plus 1 divided by negative 1 squared minus 1, which is 0 divided by 0. Again, this is undefined, so we need to go back to the original equation. When m equals negative 1, the equation becomes negative 1 squared times x minus negative 1 equals x plus 1, which simplifies to x plus 1 equals x plus 1. This is an identity that is always true, meaning that when m equals negative 1, any value of x is a solution. The equation has infinitely many solutions. Now let's look at case 2, where m squared minus 1 is not equal to 0, which means m is not equal to plus or minus 1. In this case, we can simplify our expression for x. We know that m squared minus 1 equals m plus 1 times m minus 1. So x equals m plus 1 divided by m plus 1 times m minus 1, which simplifies to 1 divided by m minus 1. Let's summarize our solutions. 1. When m equals 1, there is no solution. 2. When m equals negative 1, any value of x is a solution. 3. When m is not equal to plus or minus 1, the solution is x equals 1 divided by m minus 1. Let's look at our problem. We need to solve the equation x over a minus x over b equals a minus b, where a and b are not equal to 0. First, let's combine the fractions on the left side by finding a common denominator. We have x over a minus x over b. The least common denominator is AB. So we'll multiply the first fraction by b over b to get bx over ab. And we'll multiply the second fraction by a over a to get ax over ab. This gives us bx over ab minus ax over ab equals a minus b. Next, we'll simplify the left side of the equation. We can combine the fractions since they have the same denominator. We get bx minus ax over ab equals a minus b. We can factor out x from the numerator to get x times b minus over ab equals a minus b. Now let's solve for x. We'll multiply both sides of the equation by ab to eliminate the fraction. This gives us x times b minus a equals ab times a minus b. On the right side, we distribute ab to get ab a minus abb, which simplifies to a squared b minus ab squared. Let's reorganize our equation to make it easier to solve. Notice that we have b minus on the left side, while we have a minus b as a factor on the right side. Let's rewrite b minus as negative of a minus b. So we have x times negative of a minus b equals a squared b minus ab squared. We can rewrite this as x times negative 1 times a minus b equals ab times a minus b. Now we're ready to solve for x. We have negative x times a minus b equals ab times a minus b. Let's divide both sides by a minus b. This gives us negative x equals ab, or x equals negative ab. Now, let's consider a special case. What happens if b equals a? In that case, the original equation becomes x over a minus x over a equals a minus a. The left side simplifies to 0, and the right side also equals 0. So when b equals a, the equation becomes 0 equals 0, which is true for any value of x. Therefore, when b equals a, the equation has infinitely many solutions, or we can say that x can be any value. Let's verify our solution by substituting x equals negative ab back into the original equation. We have negative ab over a minus negative ab over b equals a minus b. This simplifies to negative b plus a equals a minus b. Further simplifying, we get a equals a, which is true. This confirms that our solution is correct. In summary, we've solved the parametric equation x over a minus x over b equals a minus b. We found that when b is not equal to a, the solution is x equals negative ab. And when b equals a, the equation is satisfied for any value of x. We'll be solving a parametric equation step by step. Let's look at our problem. Our problem is to solve and discuss the following parametric equation. A times quantity x minus a divided by b, plus b times quantity x minus b divided by a equals x. Let's solve this step by step. First, we need to find a common denominator to combine the terms on the left side of the equation. The common denominator will be ab. So we'll multiply the first term by over a, and the second term by b over b. So we get a squared times quantity x minus a plus b squared times quantity x minus b, all divided by ab equals x. Now, we'll multiply both sides of the equation by ab to eliminate the fraction. This gives us a squared times quantity x minus a plus b squared times quantity x minus b equals abx. Next, we'll expand the expressions on the left side. So, a squared times quantity x minus gives us a squared x minus a cubed. And b squared times quantity x minus b gives us b squared x minus b cubed. Setting them equal to abx, we get a squared x minus a cubed plus b squared x minus b cubed equals abx. Now we'll rearrange all terms with x to the left side and all other terms to the right side. Subtracting abx from both sides, we get a squared x plus b squared x minus abx equals a cubed plus b cubed. Now, we'll factor out x from the left side. This gives us x times quantity a squared plus b squared minus a b equals a cubed plus b cubed. Let's recognize that the right side can be factored using the formula for the sum of cubes. We know that a cubed plus b cubed equals quantity a plus b times quantity a squared minus ab plus b squared. So our equation becomes quantity a squared plus b squared minus a b times x equals quantity a plus b times quantity a squared minus ab plus b squared. Now, we need to notice an important pattern. Looking at the left side coefficient and the right side, we see that a squared plus b squared minus ab is actually equal to a squared minus ab plus b squared. So we can rewrite the equation as quantity a squared minus ab plus b squared times x equals quantity a plus b times quantity a squared minus ab plus b squared. Now we can divide both sides by the expression a squared minus ab plus b squared, assuming it's not equal to 0. This gives us x equals a plus b. So the solution to our equation is x equals a plus b, provided that a squared minus ab plus b squared is not equal to 0. Let's examine the condition we mentioned. We need to check when a squared minus ab plus b squared equals 0. If a and b are not 0, then a squared minus ab plus b squared can be written as a squared plus b squared minus ab. This expression can be shown to be 0 only when a equals b equals 0, which contradicts our assumption that a and b are not 0. So our final answer is, if a, b are not equal to 0, then x equals a plus b. Therefore, our final answer is, if a and b are not equal to 0, then x equals a plus b. Let's summarize what we've learned. First, we found a common denominator to combine the fractions. Then, we multiplied both sides by ab to eliminate the denominator. We expanded the expressions and rearranged the terms. Next, we factored both sides of the equation. Finally, we divided by the common factor to solve for x. The key insight was recognizing that a squared plus b squared minus ab is equal to a squared minus ab plus b squared, which allowed us to factor and solve for x. Let's start by looking at our problem. We need to solve and discuss the parametric equation. M squared minus 1 times x equals m squared plus 3m plus 2. First, let's isolate x in the equation. We'll divide both sides by m squared minus 1. This gives us x equals m squared plus 3m plus 2, divided by m squared minus 1. Now, let's factor both the numerator and denominator. For the numerator, we can factor m squared plus 3m plus 2 as m plus 1 times m plus 2. For the denominator, m squared minus 1 can be factored as m minus 1 times m plus 1. After factoring, our equation becomes x equals m plus 1 times m plus 2 divided by m minus 1 times m plus 1. We can now simplify this fraction by canceling the common factor m plus 1 from both the numerator and denominator. After simplification, we get x equals m plus 2 divided by m minus 1. Now we need to consider different cases. For case 1, let's assume m plus 1 is not equal to 0, which means m is not equal to negative 1. In this case, our solution is x equals m plus 2 divided by m minus 1, which is valid when m is not equal to negative 1. Let's move to case 2, where m plus 1 equals 0, which means m equals negative 1. We need to go back to our original equation and substitute m equals negative 1. When we substitute m equals negative 1 into the original equation, m squared minus 1 times x equals m squared plus 3m plus 2, we get 1 minus 1 times x equals 1 minus 3 plus 2, which simplifies to 0 times x equals 0. When we have 0 times x equals 0, this means x can be any value. This is because any value of x multiplied by 0 gives 0, which satisfies our equation. So when m equals negative 1, the equation has infinitely many solutions. Now let's look at case 3, where m minus 1 equals 0, which means m equals 1. Again, we'll substitute this value into our original equation. When we substitute m equals 1 into the original equation, we get 1 squared minus 1 times x equals 1 squared plus 3 times 1 plus 2, which simplifies to 0 times x equals 6. When we have 0 times x equals 6, this is a contradiction because 0 times any value can never equal 6. This means that there are no solutions to our equation when m equals 1. So for m equals 1, the equation has no solution. Today we will solve a parametric equation step by step following the exact algorithm shown in our example. Let's start with our example problem. First, we'll distribute the term m on the right side of the equation. Next, we'll move all terms with variables to the left side of the equation. Now, we'll factor out x from the left side of the equation. Now, we'll solve for x by dividing both sides by the coefficient of x. We can further simplify this expression by factoring the denominator. Now we can simplify by canceling the common factor m minus 1. Now, we need to consider special cases. First, let's analyze what happens when m equals 1. Next, let's analyze what happens when m equals 0. Finally, let's analyze the general case when m is not equal to 0 or 1. Let's summarize our findings for this parametric equation. Thank you for watching this step-by-step solution. Today we're going to solve a parametric equation step by step, following the exact solution process shown in our example. Let's look at our example. We need to solve the parametric equation. A squared x plus 4 equals a times the quantity x plus 2 plus b. Let's start solving this step by step. First, we need to expand the expression on the right side. We distribute a to both terms inside the parentheses. For the next step, we'll rearrange the equation to get all terms with x on the left side and all other terms on the right side. We subtract ax from both sides. Now, we'll factor out x from the left side of the equation. We can see that x is common to both terms, so we get x times a squared minus on the left. For the fourth step, we'll solve for x by dividing both sides of the equation by a squared minus a. In the fifth step, we'll simplify the denominator. We can factor out a from a squared minus a to get a times a minus 1. Now we need to consider special cases. First, let's examine what happens when a equals 0. If we substitute a equals 0 into our equation, we get x equals b minus 4 over 0, which is undefined. This means that when a equals 0, the equation has no solution and is impossible. For our second case, let's examine what happens when a equals 1. If we substitute a equals 1 into our equation, we get x equals 2 plus 1 plus b minus 4, all over 1 times 0. This simplifies to be minus 2 over 0, which is also undefined. So when it equals 1, the equation has no solution and is impossible as well. Finally, for our third case, we consider all other values of where it is neither 0 nor 1. In this case, our equation has a valid solution given by x equals 2 plus b minus 4, all over times a minus 1. This is our final answer for all values of except 0 and 1. Let's summarize our findings. We solved the parametric equation a squared x plus 4 equals a times the quantity x plus 2 plus b. Our solution process involved expanding, rearranging terms, factoring, and considering special cases. The key points to remember are: first, when it equals 0, the equation has no solution. Second, when it equals 1, the equation also has no solution. And finally, for all other values of a, the solution is x equals 2 plus b minus 4, all over a times a minus 1. Today, we're going to solve a parametric equation step by step. Let's take a look at our example. We need to solve the parametric equation x plus a divided by a minus x minus 2 a divided by a equals 3. Now, let's solve this step by step. First, let's combine the fractions on the left side of the equation. Since both fractions have the same denominator, a, we can simply subtract the numerators x plus a minus open parenthesis x minus 2 a close parenthesis, all divided by a equals 3. Step 2, let's distribute the negative sign to the terms inside the parenthesis. This gives us x plus a minus x plus 2a, all divided by a equals 3. Step 3, let's combine like terms in the numerator. The x terms cancel out, and we have a plus 2a, which equals 3a, all divided by a equals 3. Step 4, now we can simplify the fraction. 3 divided by a equals 3. Step 5, let's further simplify this equation. X minus x equals 0, so we have 0 plus 3 equals 3. Step 6, we've arrived at the identity 3 equals 3, which is always true. We can write this as 1 minus 1 times x equals 0. Step 7, we can simplify 1 minus 1, which equals 0. So we have 0 times x equals 0. This means that any real number x is a solution to our original equation. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.